In this video, I am going to show how to compute multiple correlation using R. So as before, we are going to create our own data set so that we know what to expect. I first create 3 variables, each has 50 cases and they are just IID, normal, 0, 1. So I create W, I create Y and I create Z. Let's see how they look like. For example, W looks like this, similarly for Z and W. Now I create my dependent variable X as 2 times W minus 3 times Z. So just a linear combination of W and Z plus a little bit of noise. Again R norm 50, but this time I divide by 5 so that the effect of the noise is less than the variation inside each variable. Observe that I am not using Y at all. So I do this and I get my variable X. Then I combine these into one data frame, a data frame which has got W, X, Y, Z as its column. So I do that, and if you want to take a look at that, that is my data, and you can see that it has got 50 rows and 4 columns headed as by W, X, Y, and Z. Okay, now when you are confronted with such a data set, naturally your first intuition should be to make a plot. So let's take a look at it. The plot turns out to be like this. So it's a scatter plot matrix, and you see none of them show too strong a relationship. Here is a little bit of linear thing and there is hardly any relationship. But we know that actually there is a very strong relationship. Yet none of the scatter plots which look at only 2 variables at a time is really showing you any such strong relation. And that is precisely where multiple correlation will help. Now what we want to do is we want to find out multiple correlation between X and all the other variables. So I will fit a regression using the LM function of R. I will write X tilde dot. So this basically says that you regress X on everything else. So this dot stands for everything else. You could as well have written W plus Y plus Z. So this plus does not really mean addition. It is something like a separator. So on W and Y and Z. Or if you are using all the other variables, you can save labor by simply typing a dot. And that is the name of the data set that I am using. Okay, I do that. Now, in order to get the particular R square value that we are interested, it is not enough to look at fit. If you just try to explore fit, you will see that you are getting the coefficients. So these are the coefficients of the maximum correlation linear combination. But you want the correlation itself, so you go for this line, summary fit. When you type summary fit, now you get lots of information, and in particular you get this thing, multiple R squared, and now you see that it is 0.9966, so very close to its maximum possible value 1. And that really indicates that the relationship is very strong, something that we could not see from the scatter plot. Now let's try to see if we can make a 3-dimensional plot to see the relation. Here, after all, you can see that the relation is between X, W and Z. Y is really not present. So I will try to make a 3-dimensional plot because there are only 3 variables. I use a RGL library. In general, you will not have it installed. So you have to first install the library using install.packages RGL. After that, I will say plot 3D X, W, Z because I know here that Y is not going to play any role, and RGL widget will show me the 3D scatter plot. Now, just by looking at it, X, Z, W, it does not seem like a very strong relation, but rotate it. When you rotate it, you will see that all the points are nearly exactly lying on a plane. That is why that correlation is so very strong. When you are trying to find out ordinary correlation or scatter plot, they merely show if the points are on a line. But here they are not on a line but in a plane. And that is also something that is strong correlation but strong multiple correlation. So that is the main lesson from this tutorial.